Good morning friends. Today in this video we are going to discuss neural network, which is the most interesting topic in machine learning field. Neural network is all inspired by how our brain learns and identifies things. Let's discuss how human brain learn, how we learn to identify things. If we go back to our childhood days, we started identifying things by seeing some image in textbook, poster or somewhere else. Like someone has shown picture of a parrot and we created a notion within our mind like parrot means green color bird with red beak and specific shape. This kind of elementary notion are basic foundation of our further learning. When we see parrot elsewhere, our brain tries to find these features and counts how many such prominent features are available. If it finds few of them, it quickly confirms its identification. In our example, we have perception of or notion of a parrot as a red beak, green color and its shape. Now, when we see the bird again, our brain try to count whether it has green color or not, red beak or not, and when it finds few of them, it confidently identifies it as parrot. Same thing happens in data science. Here we call perception as perceptron. Perceptron is a basic form of neural network which consists input layer having attributes from real world, weightage of each attribute, a transformation function and a state of perceptron which is either active or inactive. As per our example, perceptron of parrot will consist its shape of beak, color of beak, color of feathers and the shape as input attribute as high weightage, whereas other attributes like weight, length, etc. will hold very low weightage. This illustration shows the exact architecture of perceptron, where sum of product of attributes and weightage is called weighted sum. Weighted sum along with some bias or threshold value is called input. The transformation function operates upon this input, which decides whether a particular perceptron can be activated or not. In our case, perceptron is a step function which says weighted sum is greater than threshold value, then perceptron will be activated. When we say perceptron is activated, this simply means algorithm confirms it's parrot. Or if perceptron is for peacock, then it's peacock. In situations where it is not possible to make conclusions directly from real world input, we take help of few hidden layers. Hidden layer can be assumed as hypothetical notions that we make while making some theories. For example, if we want to identify a dinosaur out of real world attributes, then it is not possible because dinosaurs as a living being doesn't exist. All we have seen is bones, skeletons, broken eggshells, etc. But we have assumed few theories and we imagined the shape of dinosaur. Exactly same thing we do in multi-layer neural network. In between real input and output, there are hidden layers which act as intermediate conclusions while classification. Output of each layer is input for next layer. These layers can extend to any number till we get optimum value. Normally, when layers are more than 3, they are considered to be deep neural network. Unlike perceptron, here there can be other transformation functions like sigmoid, ReLU, etc. for each layer. During training process of a machine learning, we don't know weightages of each features. And learning process involves finding the set of values for all weightages in iterative way so that optimum output is achieved. To determine optimum output, cost function is defined, which is nothing but mean square of errors. And objective of training process will be to find weightages for which cost function is minimum. Since cost function is a mathematical expression, we can apply partial derivative on cost function to know in what direction weightages can be adjusted. We start with some random value of weightages and we adjust we keep on adjusting weightages in a direction where cost function is reduced in iterative way. This process is called gradient descent. Sometimes gradient descent alone is not sufficient to know minimum cost function because output is so much sensitive that we change small weightage and output changes to very large magnitude. This makes our iterations unstable. In this situation, we adjust weightages in a quantity that depends upon the quantity of output change. Means if output is changing very less, then we will change weightages more, and the moment we observe that output is changing at a large scale, we change weightage very little. We do this by including output change as a component in above expression. I hope I've been successful in explaining this topic. I will make few more videos on activation functions, back propagation and gradient descent. Please subscribe my channel and thanks to listening to me. Have a good day. Bye.